Well, hello friends, and welcome back to browser hacking. Today we're going to work a little bit on data URLs. So we want to be able to open data URLs in our browser. And what that is one of these URLs that looks like data colon, and then you have a MIME type, so like text HTML, and then comes some data. And for instance, it would look something like this, right? You would have like an HTML document here. But you can also have a, not text PNG, image PNG, and then you would probably have to say base64, and then you would have a bunch of base64 encoded data. So we don't have support for data URLs, we don't have base64 decoding, and I figured today we could try to make this happen because it would be really cool if you could encode a PNG image in text and then put that into an HTML file and view that image. So yeah, that's what we're going to do. Now I'm not completely sure how base64 encoding actually works, but we'll just look it up. And then let's see if we can. We need a PNG to test with, so I guess image PNG data URL. Just give me some. Can I see one somewhere? It's a GIF right here. Oh, I guess we can use a GIF because we have a GIF decoder as of yesterday. Peter made one, so that's pretty cool. Thank you, Peter, by the way. So, okay, so let's go here and make a test page. Data Perl, and we will just make the very simple test page. What am I doing? IMG source, clickety clack. Alright, so let's test if this works in our Firefox here. On the host, yes, we get a gorgeous little star or asterisk. So let's make this load in the Serenity browser. This will be a bit tricky. I guess the first thing we should do is just parse the URL correctly. So, and I think, by the way, the data URL format is basically data colon MIME type. And then there's like an optional base64, and then comma payload, basically. That's how I understand it, because you can omit this and then the payload is raw, but if you include base64 then the payload is base64. That's why we were able to do like raw HTML. So anyway, let's get our IDE going. And let's see. I guess we'll go to the image element and look what we have there. So currently when we parse the source attribute, then we will call load image right here. And then load image fires off a resource load. Now, this is going to look a little bit different, or ideally, the resource loader interface would be transparently able to handle data URLs. I think that would be the best. So we could just, if we can leave this code completely untouched, I think that would be great. And then the resource loader will just know what to do with the data URL. So first thing here is that we get a string as the input to load image. So the string is the raw value of the attribute. So literally a string that says data colon image slash GIF and so on. So we are passing that to document complete URL. I think the purpose of complete URL is to take a relative URL and then make it an absolute URL So if you pass it a relative URL that's relative to the current page, then, or the current URL of the current page, then it will give you the absolute URL of the thing you're trying to load. So in this case, I think basically if you call URL complete URL with a data URL, we're just going to give you back a the data URL. We're not going to try to complete it based on the current URL. So here we'll just do something like if URL, or actually if URL is valid, then we just return it. Oh yeah, so we don't even need to touch that. So all we need to do is parse data URLs. So all right, this is maybe easier than I expected. Or it's going to be a little trickier because it's going to look a bit different than the way we've been parsing HTTP URLs. So the protocol is the same. So we have protocol colon, so in protocol, and then we look for colon. Wait, what is this stuff? If consume is not this. Oh, I see. Okay. So here we should just check if string copy buffer is data. I mean, actually, we can. This is a little goofy because we don't copy into the M protocol member until later. So we'll just do this. String copy buffer. Otherwise, this code would read really awfully. And then here we'll say protocol. Okay. So if it is data, then we don't need // Rather, we want to transition to another parser state. So we just want to go to say M protocol is protocol, and then state is state in MIME type, in data MIME type. So I guess we need to also consume a colon. Well, no, we already got the colon. So, okay, so then now we're in the MIME type. Let's add that here. So in data MIME type, and then we'll also have, I guess this is not so much of a state as it is a potential thing that we'll come across, and then in data payload is a state. Okay, that's fine. So then let's implement these states in data MIME type. Then if, wait, how does this work again? We clear the buffer after we do something with it. We should just clear it here. Okay, so basically we just accumulate in a buffer, and then we do something with the buffer when we feel satisfied with the content. So when we're in the data MIME type, we are just waiting until we encounter either a semicolon or a comma. While, or no, if peak is not semicolon and peak is not comma, then buffer append consume continue. Okay, and then I guess we'll have to wrap this in one of these guys. So then we'll say MIME type is string copy buffer clear. And then if peak is this, yeah, okay, let's add a state for that. So, or if consume is not, so first we'll consume the semicolon, and then we'll consume B for base. This is a bit, I'm not super proud of this, but it works. Okay, so if anything goes wrong here, then we'll just return false, fail to parse. Otherwise, we know that it's a base 64 encoded payload. We should probably remember that somewhere. So we'll say M is base 64, true. Should we, maybe the URL class should just decode it, or I don't know. I don't know. No, let's decode it somewhere else, but let's do this. Base 60, or data payload is base 64. And then we will store this in some, can I get a, no, I can't. I wanted something to click on to jump to this place. Okay, so data payload is base 64. And then, all right, now I'm kind of thinking like, should we just, for a data URL, should we just say that like this whole thing is the payload? But that's not so convenient. It's nice if you can extract all of this from the URL class itself, I think. So let's roll with this for now. So end it in type, and then state will be state in data payload. If consume is not a comma, return false. Okay, and then transition to data payload. In data payload. So that would be, I guess we'll just put one more of these guys. Doesn't matter. Payload. We can call it byte buffer payload maybe, or string is not a terrible name. It's not gonna, I was thinking like, should it be able to have null bytes in it, but it doesn't make any sense if it's a string payload. Because the URL is gonna be either it will be URL encoded, it will always be URL encoded. So you won't have anything other than like 7-bit ASCII characters, and then the payload can be base 64 encoded in addition to that, but don't have to worry about the null bytes. So yeah, we can just use a string, is my point. So I guess here we will just keep accumulating buffer, append, consume until we get to the end. So here, if we end on if state equal to state and hostname before we finish, then m payload is string copy buffer. All right, and then we'll just say that string payload is base 64 encoded data URL. Or no, I should name it consistently with the variable here. Yeah, like that. And maybe we'll call this data payload, not just payload. Data payload, and we should also have data mime type mimtype. MIME type. Oh, MIME type. I feel like that's a single word. How did we do that before? MIME data has. Do we have MIME type anywhere in the system? Yes, there's precedent with an underscore. Okay. Then we trust in the precedent and go with underscore. So all we have here is MIME underscore type, but we never actually stored it anywhere. So I think we will store it right then and there. M data MIME type. Okay, great. Then let's go in image element. So now we are passing hopefully a data URL to resource loader. And oh, this looks weird. Let me just fix that. I'm going to fix that in a separate commit, otherwise it's going to bother me forever. The web, run Clang format on resource loaders. Formatting inconsistencies are so annoying to have like in your patch, because you want your patch to do nothing but the thing it's supposed to be doing, and if you have like these white space changes, then it just makes the patch much harder to understand because of all the noise. So better to get those out of the way in a separate commit, or leave them alone, but I prefer to fix them. So here we already have separate handling for file protocol versus HTTP. So this will be just like a separate handling for the data protocol. So now we're in the web engine's resource loader class here, just to be clear. And just like a file URL, file URLs are opened synchronously, whereas HTTP URLs, they just initiate a download in the protocol client. For file URLs, we just open the file and try to read from it. And if that works out, we will invoke the success callback. So for data, it's going to be the same. I know that at least WebKit does an optimization where they don't actually decode the data URL synchronously, but it goes to a background thread. But we're not going to be that hardcore right away here. But we might need to do that eventually. But let's not get carried away. So this would just be a matter of saying, well, first off, let's just log what's in here. Resource loader loading a data URL with MIME type, and then let's log the MIME type. Wait, what am I trying to do? Base 64 is data payload is base 64, and payload is URL data payload. Okay, so let's see if we can actually build this. And we should set it up so that this thing loads by default. The where did I put it? Data URL HTML. I think that was it. Just want to see if we can get the payload and everything come out correctly. I guess that I have touched some things and we need to rebuild some things. Oh, because of the URL.h, of course, used by a lot of things. Oh, and we need to... Wait, no, I didn't implement those things. That's why they don't show up. But they are trivial getters. So, data, MIME type, data payload. And why don't we go ahead and make those freebies since we are already... Oh, yeah, of course, now we have to we have to recompile it anyway. Maybe we should look up how base 64 actually works while this thing builds. Base 64. On Swedish Wikipedia. No, I don't want to read that in Swedish. Come on. English Wikipedia, please. I have to say, Bing is very good at not doing what I want. So, what is this? It's a... Wait, I should read this thing. It's representing binary data in an ASCII string format by translating it into a radix 64 representation. Okay, so it's just 64 different characters, and you can have a number between 0 and 63. So that's a 6-bit per character encoding. And this is the, I guess, the lookup table. Okay, so this text right here becomes this. And this is, I guess, this example right here. Okay, so this is the base 64 version, and then we have 6 bits. So the 6 bits of the first character, they all go into the top bits of the first output byte, and then you have the top 2 bits of the second character and the bottom of the okay, yeah, and so on. Okay, so that's pretty simple. We can do that. I'm gonna write a naive base 64 decoder here. I think we're not gonna get fancy, but it's not super important. So what happened here? How did I mess this up? Data URL.html. I thought that's what I put as the home page. I don't know what I did wrong. Load error page. Well, anyway, we could see that we were... Wait. We're just saying no such file or directory. Why does it say that? Make. I'm a little bit confused about why everything is the way that it is. So I feel like this incomplete half build is not the best state to be in. So let's just let that keep going, and then maybe we'll start a 64 thing. So maybe an ACK base64.h. Haven't really added new things to ACK for a while, so that'll be good. libc. I guess this goes up top. Alphabetical order. Base64.0. Okay. On. Dub. Data URL HTML. So I feel like we're not decoding that URL remotely correctly. That's probably the issue. Oh shit, because here we're forgetting to break out if we break or continue. I guess, does that matter which one we do in this switch statement? This function is a little bit too big. Wait, is this where the switch ends? No, it's the while loop ends there. That's the switch. Okay, so break or continue, it doesn't matter, because you're just going to the while loop anyway. Well, we can start sketching out that base64 thing. So this would be something like, what's that lookup table? So we got A all the way to Z, and then lowercase alphabet, and then 0, 1, 2, 3, blah, 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 blah. Okay, so static const something like this. And then we have plus and slash. All right, so that's our alphabet. And then we'll need like a lookup table based on this. So we want to be able to go from an input character to a number. So let's see, need 256 entries, and then let's say, wait, this is not a const expr. We're just going to do this in the naive way now. So void build static void build lookup table. Table and alphabet I. Okay, so now we can have a character and look up its index in this thing. And if needed, this could be done at compile time, obviously. I'm just lazy right now. And then we'll return to this momentarily after we check if our thing works. Still can't open the browser like that. Okay. All right, well, this is some progress. Loading image/GIF, base64 is true, and then the payload is nothing. So the payload is a problem. We can fix that. Probably just messing up the parse. So at the end of indata mime type, we transition to indata payload, where we just stay until the end of everything. So we concluded that this was true, and then what was the actual payload, by the way? I have to actually look at it. So we had semicolon base64 comma. So right here's the comma, and then we go to indata payload. Then we just append to buffer, and then oh, this is wrong. Why does it say in host name here? Wait a minute, did I just mess up this line of code completely? No, I just wrote in hostname for some reason. All right. Well, that settles that. Oh, and then we need that base64 thing to be correcter. So, byte buffer, base decode, base64. Something like this, maybe, would be a decent API. Byte buffer, all right. And then we'll say build lookup table if needed. Return an empty byte buffer, just so we can compile. Okay, so what are we gonna do here? We want to so it's 6 bits per character. So the common denominator, so here, yeah, so this example makes a lot of sense, right? Because you can do 3 output bytes with 4 input bytes. So I think we can just go 4 inputs bytes at a time, and then we go in steps of 4. So size ti, I is less than input size, I plus equals 4. Guess that's length, and then we'll say like input 0 is input I, and 1 is input I plus 1. So we don't want to go past the end here. So I guess we can say something like get is t offset. If offset is greater than input length, then we just return a 0. Otherwise, we'll say this one gives you a U8. Okay, otherwise we return input at offset. So now we have a safe thing that gives us empties. Okay, and then the outputs will be, so we'll have 3 outputs, and then the output and the output byte buffer, create uninitialized. Let's make it 0.1. Why not? And the size will be input length divided by 4 times 3. I think that all makes sense. I'm sure that we're messing up maybe a little bit here. We'll see. Because like it might not be perfectly even, but we can deal with that when we get there. So what was the mapping here? The mapping was that the first byte in the output is the top, the whole first input. So in 0, shifted up 2 steps, ORed with in 1 the top 2 bits of the total of 6 bits. So in 1 shifted right by 4 steps. I guess we can end off the bottom piece here just to express what we're doing here. And then the second output is the bottom 4 bits of in1 and the top 4 bits of in2. So the bottom 4 bits shifted by 4 to the left, ORed with the top 4 of in2, which is in2 shifted 2 steps to the right, and OF. Okay, and then the third is the bottom 2 bits of in2 up top. So in2 shifted 6 steps, and or the whole of in3 in the bottom position. Okay, so then I guess we have the output. We need to do some kind of a cursor here, so yeah, let's have a cursor. Output index. Yeah, so this could be written in much nicer ways, I think, but it seems like this could be good enough for us. So how would we use this? We would go in resource loader and then say, assuming that we get the payload here, I'm going to say decoded payload, or wait, hold on, if URL data payload is base 64. Then payload is URL data payload decode base 64, like that. Else, if it's not base 64, then we just say payload is data payload, which is a string to byte buffer. Okay, so now we just need base 64 here, and actually, I don't think, yeah, we didn't add any API to it. Namespace ACK, decode base 64. Okay. Let's see, libraries, let's see. Oh wait, forgot to actually hand this out if it works. So we want to do the same thing as the file thing does here. So we just want to invoke the success callback. And we do it in a deferred invoke. That means that it will happen when we get back to the event loop. I guess we can call it, we don't have to call it payload, we can call it data. Then it matches the other stuff. So we do it on the next event loop, because then if we're in the middle of something, then we don't like start calling the success callback right away, and then that allows us to write the code in a consistent way, because it gets very messy if you have a situation where some resource loads will like invoke the success callback synchronously, and other resource loads will invoke it asynchronously. It gives you like this disconnect between behaviors, and it's much easier to to manage the code if you know that it's always asynchronous or always synchronous, but never like a mix. So we should also have a failure callback. Interestingly, the error callback is always synchronous for files. So what I was just saying is not true for files. We should probably make that asynchronous as well. All right, this thing again. Okay, so let's see. We got the PNG payload, looks good here, but we're trying to parse or load it as a PNG and it doesn't work. That makes sense? Because it's an image GIF. Now I don't think we should care too much about the MIME type. We're just gonna like hand it to the image decoder and hope for him to do the best that he can. But I guess we can dump out whatever the decoded data was so we can see what it looks like. And then we can try to work out why it doesn't function, because maybe I just messed something up in the base64 implementation. We'll see what comes out of it. So data size, and then we'll printf something like this. And then if I is divisible by 16 and I is not 0, of course, then we'll do a new line, something like that. We can see what that looks like. Also, what's up with not working? The automatic load should work. Okay, so here is what we get out, and maybe we can decode this on Linux somehow. Base64 -- decode pipe to hex.c. Okay, so it's a GIF certainly, but we're getting the wrong bytes. So I messed something up. All right, let's see what we messed up. Oh, wait. I'm not going to the lookup table. That's why it's not working. We have to go to the lookup table, obviously. So we need to look in stable for these guys. Actually, we can even do that in the get function. And we'll cast the subscript so that it does what you would expect. And there it is. That's basically it. I think we don't have support for GIF transparency probably. Didn't even test that, but I think that's basically basically works. Cool. We should try it with a PNG. So let's try it with this awesome new icon that Andreas made today. I really love this. It was just added like just before I started recording here. It's made by, where is it? I have to advertise. Made by Andreas. Andreas, I hope I'm pronouncing his name right. It's so close to mine, yet so far away. Such a good icon. Look here, it even has a 16:16 version. But I wanted to use it for something, so we'll turn it into a base64 encoded string. So cat base res icons 32:32 app browser pipe to base64 encode. Does that work? just like that. Okay, so that worked. And then I don't want those pesky new lines messing up my jam, so how do I get rid of those? Disable line wrapping. Yes, like that, perfect. So let's see. Base, home, unknown, dub, data, URL. Data image PNG. Look at this. How cool will it be if this works on the first try? I think maybe it'll work. We'll see. Nah. Why didn't it work? Invalid PNG header. Okay. All right. So this is the PNG, I assume. Oh, it starts here. Okay. So this gunk. Wait, can we even open it in Firefox, I wonder? It loads here. Okay, so it should work inside of our browser as well. So how are we messing that up? So we're doing image GIF just fine, and then image PNG. This is our payload. I guess we can double verify that the payload came in correctly at least. So we'll do like data image PNG. So that works. So he has the right payload. He's just not base64 decoding it right. So I guess we can just cross-reference what we have here. Well, we already have the PNG, so app browser less. Okay, so it starts out just fine. 89 through 52. So everything's looking pretty good. Does it end wrong or something? How does it end? 82 followed by a 0. So we have a 0 here that's not supposed to be there. Outside of that, everything is good. Is that 0 just screwing everything up? I wonder. Why do we have the 0? Is it because of there was like a trailing character? We had a trailing equal sign. This guy right here, it's not in the alphabet. So I guess that's like, it's just like a dummy thing, so that you get like an aligned number of bytes. That's interesting. So let's see, maybe we'll do this a little bit differently. So we don't actually know exactly how long it's going to be until we get to the end and look at if there's any like padding characters. So let's try. Again, this is not meant to be the most beautiful and efficient decoder, so we can definitely improve this, but we'll go with this for now. So output, and we need vector. Okay, so vector of U8s, and then here we'll just say wait, how does this work? Base64 Wikipedia. Do they say something about this thing? Padding, yeah, they call it padding even. Okay, so padding characters might be added to make the last encoded block contain 4 base64 characters. Right, so it's to get the correct alignment. So you're always in a multiple of 4. So if you have padding at the end, there are only 2 significant input octets, or when the last input group contains only 2 octets, all 16 bits will be captured in the first 3 base64 digits. The 2 least significant bits of the last content-bearing 6-bit block will turn out to be 0 and discarded. Okay, so I guess in case the input is literally an equal sign, then we should treat it as a 0. So basically, like here, if input at offset is the equal sign, treat it like zeros. And can do something like that. And if the last byte is missing, if we have one padding, that means that it's a 2-byte sequence. If we have 2 paddings, it means it's a 1-byte output sequence. Okay. So I guess that means that if in 3 is non-zero and right, so if this one is not present, then we don't do the last byte, and if this one is not present, then we skip that guy as well. Wait, I have to... Can I turn this into pipe buffer copy? Oh, this is so hideous. But whatever. Well, now it's worse. So, how did I mess it up this time? I guess... Oh, yeah, right. I can't just look at the zero-ness of this thing. I have to actually look at if there was actually padding. Wait. Oh, how do I write this in a nice way? Like this is padding is true. And we will default this to that. Okay. That's slightly awkward, but it doesn't have to be beautiful right now. Okay, so now we can parse this guy again, but not the other guy. So let's look at the output, and it still ends in 0, 0. So we're messing that up. So I guess these are the last 4 characters, YII equal. And just to make sure this is a full build, yes it is. Oh wait, hold on. I'm not looking at the right thing here. I was saying into is padding in both. Okay, there we have it. Cool, 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 cool. That's pretty good. So, one of the world's least efficient base64 decoders. You are welcome. But it works, so that's awesome. Now we can load data URLs. Very nice. And then we have some optimization work to do, but we're not going to do that right now. And I'm just going to ignore the whole browser can't load the file correctly if it's in the ini file. We'll just ignore that. So starting with the ACK URL class, parse data URLs, teach URL how to parse data URLs. Okay, and then, oh, and we have to add the base64 stuff. Heck, add a simple and inefficient base64 decoder. Yeah. Is that how you spell that? Yes, base64. No dashes or nothing. Oh, crikey, I forgot the copyright header. Someone asked about why I keep putting copyright headers and everything. It's because I like that if somebody else works on the system, they can put their own name here, so that people can take credit for the things that they build in Serenity. I don't want to have like this implicit license where, oh, everything is copyrighted by me, but rather I like it that if people who work on the system, they can put their own name and put their own email address and their own mark on everything that they do if they want, and if they don't want, that's fine too. But I think it's nice to do that. That's why it's one in every file, because then if you work on something, you can put your own little tag there, instead of just a project-wide thing. What am I doing? I'm pressing all the wrong buttons here. So there's that, and git add this guy right here. No, wait, hold on. I'm still fixing up the base64 stuff. Right? That was, yes. Oh, and we should at least add a link to it on the functioning homepage. Does that not function either? Is this just broken and I haven't, or I am so confused. Why does the browser not start? Protocol not implemented in all. Maybe we should look at why this is happening, because it's a bit weird. But let me just commit first. So commit this and that, and then say were we doing something weird in some other case here? If your load protocol is data, then do something. Right, otherwise do nothing. And we should probably not do this printf business. Yeah, that's pretty cool. Web support loading data URLs transparently via resource loader. This is pretty darn cool. I have to say, it is pretty darn cool. So let's just take a quick gander here at what's going wrong with the browser when we try to start up. What are you so mad about? You are failing in load error page. Why are you even getting a load error page? HTML view 429. Failed to load error page. Is it that we are now failing to parse this particular URL? And previously was working and I'm just breaking it with my changes? I mean, I guess it's possible. If so, then I need to stop breaking it. Yes, I'm only assigning to M protocol if it's data. That's a very, very stupid bug. That explains why this was happening. So we'll do like that instead. Or we can do it here. No, we can't do it there. That's the whole point. And then we don't need that guy. We can just do that. String copy. Okay. Well, it's a good thing it was my fault and I broke it right now. And it's still broken. How am I breaking it then? What's wrong with it? Am I rebuilding everything that's needed? Probably. So if state is in data mime type, but if it's not, if it's a file URL, we just carry on, blah, 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 blah. Oh, and if buffer is empty, I've already emptied at this point. Okay, so that's a bit weird. If buffer is empty. Oh, that's so weird. Okay, this parser needs a little bit of an overhaul at some point, I think. But it is livable. Can do this at the end also. Doesn't make much of a difference. Let's test the ACK tests, because we have a URL unit test. And I was just not even testing it. Okay, everything is green. We'll just put that in there. Okay. Data, URL, HTML, and we are good. Yes, everything is good and beautiful. So, finally, maybe we can just call it a day here, actually. So I'm just going to bring up that icon again because I like it so much. Look at it. And here it is again. Very cool. Okay, so this will be the end of today's video. We managed to get data URL parsing, base64 decoding, and then we integrated it so that we can now load images. Well, really, we should be able to load any resource that is a data URL. So let's see what happens if we do this. I don't know what's going to happen, but we'll see. It loaded, and then it looks like ass up here because it doesn't serialize correctly. So it's actually an opportunity to fix one more thing. To string, this is going to have to be different. So if m protocol is data, then we'll take an alternate path here. M data mime type. And then if m data payload is base64, builder append. Append comma, and then builder append m data payload, and then return builder to string. I think this will work beautifully. Serialize data URLs, or make URL to string produce a data URL for data URLs. Okay. And let's try that out. Will it work? Let's make an H1. Hi there. Oh, no. Hello, friends. Ooh, this is scary. Oof. And look at that. It's serialized back into itself correctly. Awesome. Okay. So that's going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out. Well, we get some good features down here, I think. Some very nice stuff. And I hope you saw something interesting. And I hope I'll see you next time. Bye.